So hello everyone, welcome back on my channel. My name is Hans-Jürgen Schönig, and today I'm gonna share a topic with you which is really close to my heart, which is really super useful. It's gonna be one of the shorter videos, but I think the topic is sufficiently important to justify a dedicated video because what you're gonna see today is gonna solve so many practical problems, and I hope it's something that is useful to you, and I hope it's something that's gonna make your life a bit easier on the Postgres side. Okay, so let's get started. Today's topic is transactional DDLs in Postgres. Okay, but as always, before we get started, let me quickly introduce myself. So, my name is Hans-Jürgen Schönig. I'm the CEO of CYBERTEC. We are a company focusing on Postgres, and we've done so since 1999. So we are a bunch of Postgres fundamentalists, I would say. We're serving huge customers around the world. So we're located in Poland, Switzerland, Estonia, Austria, Uruguay, South Africa, and Mauritius, with more locations to come shortly. So I invite you to check out our website and figure out more. So if you need anything, migration, Kubernetes, Postgres, whatever, just feel free to reach out to us. So let's get started with today's topic. How does Postgres handle DDLs? So in many, the first thing is, why is it relevant at all? I mean, some people might wonder, well, why is he going to talk about this thing in the first place? And the reason is that many commercial databases, especially Oracle, have huge issues around transactional DDLs. So in Oracle, if you do a create table, it's going to be implicit commit. There is no such thing as begin, create table, rollback. I mean, you can do that, but it's not going to do you any good because the create table has already triggered an implicit commit. Okay, so you cannot just roll back, let's say, the creation of 500 tables as you could do it in Postgres. You know, you have to go back in time and blah blah blah. So it's a bit more complicated than you would see have it in Postgres, and this is going to make testing very hard. So if you got software developer which is going to work on some testing, he's hacking up the data structures, create table, etc. You want to deploy it fails, right? So you want to run it again, but 50 tables have already been created, 10 are missing, 20 are wrong, functions are missing, functions are there. That's going to be a huge mess, right? So because there's no such thing as atomic deployment if you don't have transactional DDL. So you can do a lot of tooling around it, etc. But it's still always going to be tricky and cumbersome and inconvenient, right? So it's certainly worth checking out this whole thing on the Postgres side and see how we do that, which is a lot easier, a lot more convenient. Okay. So let's take a look. I've created a simple database here. I called it demo. And obviously my database is empty. But in the next step, what I'm doing here is I'm starting a transaction and I'm creating a table called foo. There's just one column, doesn't matter anyway. And if we list the relations there, we're going to see the table. Okay, so we can insert into this table, we can update, we can modify, whatever you want, right? But if we roll back, what we see here is it's gone. So obviously, only our transaction can see this table, and the table is not seen by anybody else. Okay, so this is something that's the standard transactional behavior. You're going to see your stuff, somebody else is going to see his stuff, and if you commit, then hopefully stuff is going to be visible. Okay, so that's very specific to Postgres, because if you do create table, it's not going to be an implicit commit as you would do it in Oracle. Okay, so we can roll back. So if this thing fails, nothing happened. No tables got created, no rows are going to be there, no indexes, etc. So no implicit commit. what is important here is that this is going to work for the vast majority of instructions. Create table, alter table, create index, create type, create user, create pretty much everything. Okay, there are just a couple of exceptions here which are worth mentioning, and they are mostly related to multi-transactional stuff. So let's take a look. What does multi-transactional mean here? So let's create a table again, a create table foo. There is no explicit transaction block here, so obviously we committed the transaction. So we create the table, then we create an index. Let's call it index 1 on this foo table. As you can see, it was properly created inside our transaction. And then as a second instruction, what I'm doing here is create index concurrently on the same table, just with a different name. And what we get here is an error message which says create index concurrently cannot run inside a transaction block. The reason is that create index is part of a transaction, but create index concurrently is a bit more difficult. It's a bit more complicated the way it's been implemented, so it's not going to be the same transaction. So there are some exceptions to the rule, which is drop database, drop table space, stuff like that. But for the vast majority, which are relevant to software deployment, create table, alter table, drop column, create user, create type, create domain, collations, etc. They can all be within the transaction. They're just some small restrictions, which drop database, and what really might be nasty in the real world is create index concurrently. But that's pretty much, create index concurrently is pretty much the only thing that's going to hurt you in real life. Okay, so those are the only exceptions to the rule. Okay, so what's the use case? I stated it already. First of all, clean deployment. So you're hacking up in SQL script, you run it, roll back, you run it, you roll back, you run it, you roll back. And the thing is, you can test without leaving anything behind. So if you're writing a C program, you compile it, so you're killing the old binary. Okay, create a new binary, you compile it, you create a new binary. In SQL, it's always like you have a database, but if you move from one version to the next, it's patching, right? So it's like incrementally creating a binary, if you want to see it that way. So it's a bit more complicated. So clean deployment, proper undo, easier deployment, and or simply no deployment if things go wrong. So this is really something which is super important for updating your data structures, for deployment, etc. So it's a really nice feature. It's in my judgment one of the best features in Postgres we've got in the whole database. Okay. So conclusions, it's pretty cool. And also keep in mind that for those who are used to Postgres, this is not something you should take for granted. I mean, it's one of the best features of Postgres. The implementation is, well, surprisingly simple, if you can call it simple. Well, that's one of the best features in Postgres. So I would invite you to check it out. And yeah, so if there are any questions regarding transactional DDLs, feel free to get in touch with us. Follow us on Facebook, follow us on Twitter. Leave a comment in the comment section below. Maybe you want to suggest some topics you are especially interested in. And well, finally, ring the bell, subscribe to the channel, and share with your friends. And we're certainly looking forward to hearing from you. So have a nice day and successful deployment.